Hello friends, this video on differential equation part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 7. So now let's understand the methods to solve first order, first degree differential. Please note, we'll be solving only first order and first degree differential equation using this method. So first order, first degree equation is of this form, dy by dx, because this is first order now, and there is no square or something because it's first degree, is of this form, is equal to f of xy. Now if I'm able to write this f of xy is equal to g of x in h of y, two functions multiplication, then only I can use this method. Please note, this method is only for the form where I can write in this fashion, dy by dx is equal to h of y into g of x, two functions in terms of x and y, and both are in product form. If I can write in this fashion, what I can do is I can make this guy this side, so this becomes 1 by hy dy, correct, and this becomes gx dx. See, you take 1 by hy dy, this guy into dy is equal to, you take dx this side, this becomes gx dx, right? And then what do you integrate both sides? Once you integrate, you will get the solution. So this is a case where I can write in this fashion. We'll solve some examples to get the concept clear, but this is how we'll do. So if I have my equation, first order, first degree of this pattern, if not this pattern, convertible to this pattern, I can very well solve the equations. Let's take one example. It says dy by dx is equal to 1 minus cos x by 1 plus cos x. So if you see, this guy is a function in x and there is no function in y actually. You can assume this guy is 1. So if you can see this guy, I can write this guy in this form. Correct? Where my g of y is equal to 1 or f of x is equal to this guy, 1 minus cos x by 1 plus cos x. That means I can use the formula which I told. So this guy will become actually dy is equal to 1 minus cos x by 1 plus cos x dx, right? You integrate both sides and then you get the answer, correct? Integrating is not difficult for it. Why? Because we have done this kind of question. 1 minus cos x I can write as 2 sin square x by 2, and 1 plus cos I write generally 2 cos square x by 2, right? So cos square x by 2. So with this I get, this is nothing but tan square x by 2, and integration of tan square x by 2 I know. So this is nothing but integration of tan square x by 2, correct? Tan square x by 2 further we'll write as sec square x by 2 minus sec square x by 2 minus 1, because we know integration of sec square x by 2, right? The whole thing dot dx is nothing but integration of dy, or you get y is equal to, you integrate this guy, sec square x by 2 is nothing but 2 tan x by 2, 1 becomes x and plus c. So that is my answer. Please note, this is general solution because a term c is involved, right? This is a general solution. So when we introduced this chapter, we talked about general solution and particular solution. So here we got general solution. We'll take some examples where we'll find a particular solution also, where we'll be given some value of x and y. With that we can put in this value and we'll get the value of c, and then we get a particular solution. Here we got general solution. So what we have done here, we knew that dy by dx is nothing but f of x into g of y form, where g of y is 1 and f of x is this whole thing. So we wrote in this fashion, and then the only challenge was to find integration of this, and we have learned how to find integration of this in our integral chapter. Let's take one example. Dy by dx is equal to root 4 minus y squared dy. Same thing here also I can write in this fashion, dy by root 4 minus y squared is equal to dx. The trick here is, on the left hand side put everything on the form y, on the right hand side put everything on the form of x, right? So here you have this things in the form of y. In the form of x there was nothing, so I did nothing here. In the last example, in the form of y there was nothing, but in the form of x there was a lot of stuff. 1 plus cos x, 1 minus cos x I put that. And that's why we say that dy by dx has to be equal to some f of x and g of y, right? That's why you can put this g of y in this side and d of x in this side. So that's what we do. We integrate now. So root 4 minus y square is nothing but 2 square minus y square, you can see, right? 2 is nothing but 4. So integration of this we know is nothing but sine inverse y by 2, and this becomes integration of dx is x and one constant. So you get y by 2 is nothing but sine of x plus, and that is my answer. Here also if you see this is a constant term, so it is also a general solution. So not a great thing here with a simple question. We'll take one example. Dy by dx is equal to plus y is equal to 1. So this also is very simple. Actually you can write as dy by dx is equal to 1 minus pi. If you see there is no x component, only y component here in this side, so I'll write this guy as dy by 1 minus pi is equal to dx. Correct? Integrate both sides. So this becomes minus log of 1 minus pi, and this becomes x and plus some constant, and that is my answer actually. So if you want further, what you can do is you can say that 1 minus y is equal to log of 1 minus y is nothing but minus of x plus c, or 1 minus y is e to the power minus x plus c, or y is equal to 1 minus e to the power minus x plus c. And if you want to find the final equation in terms of y is equal to something, right? So you can do this way also, and thus you get this answer. Correct? Here also if you see there is a constant term here, so this guy is also a general solution. Okay, let's take one more question. Sec square x tan y dx plus sec square y tan x dy is equal to 0. So we have to convert this guy into fx gx form actually. So let's try to do this. So what we can do is we want to put everything on this side, right, to be of x form, not y form, right? So let's divide this guy by 10y. So with this what will happen is this guy becomes only x form, right? And this guy has now sec square y and tan y. This guy has one x form. I want to get rid of this, so let's divide both sides by tan x also. So what you get actually here is tan y cancel, you get sec square x tan x dx plus tan y sec square y tan y dx. This is what you get. Correct? Sorry, sec square x by tan x actually, and sec square y by tan y. Correct? This is what you get. Is equal to 0. Or you can say that sec square x by tan x dx is equal to minus of sec square y tan y dy. And you integrate both sides. So if you see this side has all x part, this side has all y parts. To get this, what I have done was, see, if you see this guy had one extra y part, so I divided both sides by pi. This part is gone, right? This guy had one extra x part, I divided both sides by x. This part is gone. Sec square by tan x again is acceptable because this will again be x part. That's what I get. I have to solve this. In this case, if I take tan x as t, if I take tan x as t, then if I take tan x as t1, let's suppose for this guy, you get sec square x dx as dt1. Correct? So this guy becomes integration of dt1 by t1, and there is nothing but log of t1, and there is nothing but log of tan x. You take right side now. Here you take tan y as t2, right? So you get sec square y dy as dt2. So this becomes dt2 and this becomes t2 minus, this becomes minus log of t2, this becomes minus log of t2 is nothing but tan y plus some constant I get, and that is my answer. Correct. If you want to solve further, this becomes log of tan x plus log of tan y, that is log of tan x into tan y is equal to c. Correct, and that is the answer. Or you can also say tan x into tan y is equal to e to the power c. So you can simplify as much as you want, but this is an acceptable answer. So what we have done, we have the logic I told you, right? We should have dx and dy component. This guy should have all x things, they should have all y things, and that's why we did. We divided by this guy, this guy, this guy, this guy, so that to make sure that we got all x component on this side and all y component on this side. Let's take one more example. E to the power x plus e to the power minus x dy is equal to e to the power x minus e to the power minus x dx. So here I can write very simple, dy by dx is equal to e to the power x minus e to the power minus x by e to the power x plus e to the power minus, right? Or let me put dx here only. So what I have done, I have put dy here because there is no y component in all these, and dx here, all the x components. Just integrate. Correct. So let's do one thing. Let's take this guy as t. E to the power x plus e to the power minus x is equal to t minus. So you get e to the power x minus e to the power minus x dx as dt. So this becomes, this whole thing becomes dt by t integration, and this is y. So you get y is equal to log of t plus some constant, and that is nothing but log of e to the power x plus e to the power minus x plus some constant, and that is my answer. So nothing great sign here. Also we have dy and dx, we got all y component here, there was nothing here, all x here integrated. Let's take one example. Dy by dx is equal to 1 plus x square into 1 by y square. Very simple question, because this is, if you see, fx and this is gy, already we have been given in this form. So I can say that dy by 1 plus y square is equal to 1 plus x square dx. Just integrate both sides. So this becomes tan inverse y becomes x plus x cubed by 3 plus c, and that is my answer. Or you can say y is equal to tan of x plus x cubed by 3 plus c. That's the answer. And please note here also, this is the general solution. Till now what we have found is all general solution only. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.